And then you have sine x negative, which then would create this red line. And if you have y equals negative sine theta like this, well, that is equal to this one here. Same with tan theta. If I substitute a negative x value here, I will get a negative tan theta like that. So our even odd identities are cos of negative x is equal to cos x, sine of negative x is equal to negative sine x, and tan of negative x is equal to negative tan x. So you can just take the negative out of the kind of the angle part and bring it to the front when it comes to odd functions. And for even functions, the negative sign just, changes to positive. There's no change. All right, now we are getting into a little bit more difficult identities. And these are our cofunction identities. Okay. The cofunction identities describe trigonometric relationships between complementary angles in a right triangle. So we have cos of pi over 2 minus x is equal to sine x. What does that mean? Well, I know that, so we know that if I have a right angle triangle and my angle is, say, theta and then 90 minus theta, because these two angles have to add up to 90. So if one is something, then the other is 90 minus that amount. If I were to take sine of theta, that would be opposite over hypotenuse. If I were to take the cos of this value here, that would also be x over r, because the adjacent value would be x and hypotenuse would be r. So what they're saying is sine theta is the same thing as cos pi over 2 minus theta, which is right over here. And similarly, if you're doing it with sine, pi over 2 minus theta is the same thing as cos theta. So these things are your cofunction identities. Here we have equivalent trigonometric expressions by comparing principal angles drawn in standard positions in quadrants 2, 3, and 4 with the related acute reference angle in quadrant 1. So if I have sine of pi minus x is equal to sine x, and that's in quadrant 2. If your principal angle is in quadrant 3, sine of pi plus x is equal to negative sine x. And if your principal angle is in quadrant 4, then you have sine of 2 pi minus x is equal to negative sine x. So these are some identities that you should memorize. There are a bunch of identities that you will be memorizing to use to help you solve the examples in this unit. So let's do another example here. All right, we're going to prove the cofunction identities using transformation identities. We know that left-hand side, let's see right-hand side, cos pi over 2 minus x. I'm just going to erase this part because I'm going to need this to write. So I'll just put the rs here. So cos pi over 2 minus x. What can we do here? Well, I'm going to rewrite this. And I'm going to write x first, like that. And then I'm going to factor out a negative 1. This is going to be x minus pi over 2. We have a negative value here. We know that since cos is an even function. Okay, so remember negative from our previous example, we used our even and odd functions. So if I have a negative angle, a negative sign kind of there, you can just, get rid of it because it's an even function. So that negative 1 just kind of disappears using that that knowledge that we have. And here we have cos of x minus pi over 2. And this should look familiar because this is our transformation function. Cos of x minus pi over 2 the same thing as sine x. So this is equal to sine x. And now we have left hand side is equal to right hand side. Okay. We're going to do the same thing now for this other example here. So left hand side, right hand side. Here we have sine pi over 2 minus x. And then here we have cos x. And we know that I'm going to work on the right hand side this time. We know that these two things are equivalent. The first, here I'll write it a bit clearer. We know that cos x is the same thing as cos of negative x. Since it's an even function, we know that's exactly the same. Now, what else do we know from this? Let's see. Well, we have this transformation identity, correct? So if you look at this transformation identity, we know that cos x is equal to same thing as sine x plus pi over 2, right? So instead of cos x, we're going to write cos of negative x, and that's equal to sine of negative x plus pi over 2. Here, let's write it over here. So we're just using basically this formula here, except instead of x, we just have negative x here and negative x here. So cos of negative x is equal to sine of negative x plus pi over 2. This is a transformation identity. Because remember, the difference between a sine x and cos x is just the addition of pi over 2. So what now? This looks awfully some. Wait, no, that they are the same actually. Just a rearrangement. There's nothing really happening here. Just putting in pi over 2 first, minus x, and there you go. Left hand side is equal to right hand side. We're done. So that's how you can prove these identities here, these cofunction identities. Let's move on. We are now going to do example 3, in which we are applying these identities. So given that sine pi over 5 is approximately equal to this value here, use equivalent trig expressions to evaluate the following. So cos 3 pi over 10. So how would we use our knowledge of sine pi over 5 with this? Well, we know that the first thing is this has to do with sine. So we have to change the cos into a sine. And our angle is 3 pi over 10. So if I use this formula here, and I say that, okay, let's see, my x value is 3 pi over 10, right? That's x value. Let's see, which one should I use? Let's use our cofunction identities, actually. Let's use these ones. So here, we're gonna use this one here. So here, we're going to use this. We know cos 3 pi over 10 is x. X is 3 pi over 10, so we're going to rewrite it in terms of sine. So now sine, this is equal to sine of pi over 2 minus 3 pi over 10. Obviously now at this point, we're going to common denominator everything, so 5 pi over 10 minus 3 pi over 10. And that's equal to 2 pi over 10, because 5 minus 3 is 2. And then we can simplify, factor out the 2, so that's pi over 5. And we've basically rewritten it as this, so we know the answer is 0.5878, approximately. So this is how we use our cofunction identities. Just label your x value, and whatever your x is, just plug it into it, and then you can use it that way. So I'm going to do the exact same thing, except now for this example here, cos 7 pi over 10. Exact same thing, my x value is 7 pi over 10. So I'm going to rewrite this in terms of sine. So sine pi over 2 minus 7 pi over 10. And then we're just gonna, let's see, in common denominator, 5 pi 10 minus 7 pi over 10 sine negative 2 pi over 10. And that's obviously equal to sine of negative pi over 5. Now here, the information given was for an angle of positive pi over 5. But we know that sine is an odd function. Because sine is an odd function, this negative can be taken out, and it can be written as negative sine pi over 5. Had this been a cos function or an even function, that negative could just disappear, and they're equivalent to the positive angle. So here we have the answer being negative 0.5878 approximately. There we have it.